Hi guys, it's Mrs. Dietrich. How's everybody doing? These are the notes for 7.1. I'm going to go through and do all the examples. What I do is I pause after every one and then start the next one. You shouldn't notice any different. It should run continuous for you. But feel free to stop and pause the video whenever you need to in case you had a question or you wanted to see something again. So, I'd like to introduce you into something that might be almost as old as me, not quite. It's my whiteboard. I really took this to college, no joke. So here it is, back again, brought back out for you guys to help you. So welcome. We're going to do notes for 7.1. So this chapter has to deal with Pythagorean theorem is a big concept, simplifying radicals, and knowing how to square a number. So the first lesson is finding square roots. So what are perfect squares? So on the left, I gave you kind of like an example of what 1 squared is, 2 squared, 3 squared. It's a number with integer roots. So when you square root 25, when you square root 16, square root 9, square root 4, square root 1, what you get are its roots, but the numbers themselves, 1, 4, 9, 16, 25, like 81's 1, 100's 1, when you square root it, you get 2 integer roots. So those are the numbers that are the perfect squares, the 1, the 4, the 9, the 16, and the 25. So what are not perfect squares? So if I gave you a few examples, I gave you 2, 11, 22, 14, and 31, because if you look at their factors, none of them are the same. So like 2 isn't perfect because 1 times 2 and 1 and 2 aren't the same. Just like 14. You have 2 times 7, 1 times 14, but neither one of them are the same, and that's why 14 is not a perfect square. So what are square roots? Square root of a number is a number that when multiplied by itself equals the given number. Every positive number has 2 square roots, 1 positive, 1 negative. But again, perfect squares are when you take the same number multiplied by itself to give you that number. So I'm going to do the square root of 49. So since 7 times 7 is 49, negative 7 times negative 7 is 49, its roots are 7 and negative 7. Okay? So 64, what times what gives you 64? Well, 8 times 8 is 64, and so is negative 8 times negative 8 is 64. So these roots are 8 and negative 8. So I went through some of the properties of square roots at the table at the bottom. So take, for instance, the square root of 25. So the square root symbol is that check mark kind of. The radicand is the number or term underneath the square root. And then we have a positive and negative root. Positive would be like this. So you don't see anything over here. It's just assumed to be the positive root. If you want a negative root, then you would do a negative on the outside. So that would make it negative. So then we have, well, what happens if you want the 2 answers? Okay. So then it's called plus minus. So that just means there's 2 answers, a positive and a negative. So the other thing I wanted you to think about is the square root, and we'll talk about this later. It's actually x to the 1/2. This will come up later in the notes. So if you're trying to wonder in terms of order of operations, when do we do this? Because square roots are actually a power. We'll talk about this later, like I said. You do it when you do exponents in order of operations, just to give you an idea. So then I have a question for you, because maybe you're wanting to know, well, what's the square root of, say, negative 25? Does that exist? Okay, well, here's the deal. It does, but not right now for you guys, because when you square root a negative number, they're actually imaginary numbers, because what are factors of negative 25? Well, you could do 5 and positive 5. You could do positive 5 and negative 5. So the fact that they're not the same factors, you can't take the square root of it. So the idea is you can't take the square root of negative numbers, and we're not going to be doing that this year. You'll do that when you get into high school, and you will talk about a system of square root of negative numbers, and that'll be something else that you learn. But we're not going to deal with any square roots of negatives, so you don't need to worry about that right now. All right, so just something to know, you could do the square root of a over b, and you could actually separate it into the square root of the numerator and the square root of the denominator. That's kind of a little trick. You'll talk more about this when we do exponents. We'll get to that in a couple chapters, and you'll definitely talk about this more next year. So remember order of operations, like I kind of already introduced. The square root of x is x to the 1/2 power. If you had the third root of x, it would be x to the 1/3 power. If you had the fourth root of x, it would be x to the 1/4, and it goes on and on. So when do you do square roots? It's considered at, so when you do PEMDAS, it's actually at the exponent level because that's what square roots are, okay? All right, don't forget that the square roots like this, I think on your calculators, I can't remember if you have to hit second square root or square root, but your calculator can do all of this for you. So example 2a, square root of 25. Since there's nothing here, they just want the positive root. Okay, this one you could do negative, and you can do square root of 9, square root of 16. So that's negative, because they want the negative root. So that's 3 over 4. This one they want plus minus, and you can actually write plus minus. It is not a key on your calculator. You could just write it, and it just means both the positive and the negative together. So the answer to that is 1.5. If you wanted to write 1.5 and you wanted to write negative 1.5, you can write them separate, but this is kind of nice where you do it in one spot, and then I know you're referring to the positive and to the negative root. This one they're expecting a negative, so this is negative 9. Plus minus, they're expecting both, so next square root of 9, square root of 64. So this would be plus minus 3 over 8. So again, if you wanted to write 3/8 and negative 3/8, you can. You don't have to. You could do the plus minus. And then the last one, the square root of 4.8, is simply 2.2. And again, your calculator has a square root function already built in. You just type it in. And I think with your calculators, you'll get the radicand and then, or the radical symbol, and then you'll get a left parenthesis, and then you'll put your input. It's probably a good idea to end parentheses, especially when you put in like longer expressions. I believe it'll still figure it out even if you don't forget the right parentheses to end it, but it's really good habit if you start a set of parentheses that you should end it. Okay, something about square roots and squaring a number, just like you have adding and subtracting their opposites, just like you have multiplying and dividing their opposites, we say they're inverses of each other. Squaring a positive number and finding a square root are considered inverse operations. So evaluating an expression. So we're going to go through and do example 3. So 5 times the square root of 36 plus 7. So according to PEMDAS, you don't have parentheses, but you have exponents. So this is really 36 to the 1/2 power. So you're going to do 5 times, do the square root of 36, which is 6, plus 7. Then you times before you add. So you get 30 plus 7, which is 37. Okay, part B, you have a quarter plus the square root of 18 divided by 2. Well, instead of breaking it up into 2 square roots, square root of 18, square root of 2, you can actually do 18 divided by 2, which is 9. So I'm going to do a quarter plus square root 9, which is 3. So I'm going to get 3 1/4. Or I have those variations. You could have 13/4. You could have 3.25. It's all the same number. So I don't know if you noticed part C, you're squaring a square root. So I just want to show you, when you square root 81, you get 9. But then when you square it, you get back 81. So a little trick what happens when you square a square root? You get the term or the number that's under the radical. So when I square square root, I get back the 81. Again, squaring and square rooting, they undo each other. So that's why that happens. So this is a difference of 76. All right, part D. Square root 144. 2 times 12 minus 30. So do the 2 times 12, which is 24. Take away 30, you get negative 6. All right, this one, you could do the same thing. I would divide first rather than doing the square root of 36 over the square root of 4. You could. So I'm going to get the square root of 9 plus a 6. I'm going to get 3 plus a 6. Sorry for the shading. If you can remove the board, you get 3 and 1/6. 3 and 1/6. All right, last one. Again, we have the squaring a square root. So you could square root 49. You get 7, but 7 squared is 49. So you get 49 minus 49. You get 0. So I'll let you look at those. All right, last example. This is kind of like a word problem using the area of a circle. So the area of a crop circle is 45,216 square feet. What is the radius of the crop circle? So if you know the total area, and for pi, we're going to use approximately 3.14. You can go back and find the radius. So I'm going to substitute in my area, put in for the value of pi, and put r squared. So in order to solve for r squared, we have r squared, but in order to get to r, we have to do something with r squared first. So that's our goal. So in order to get r, we have to get r squared by itself. So I'm going to undo and divide. Okay. So my r squared is equal to 14,400. Okay. So in order to get r from r squared, you're going to want to square root. So you're going to square root both sides, and you're going to get 120 equals r. So that's 120 feet on that one. The next one has an area of 50.24, so I'm going to do area equals pi r squared. Okay, put in my area, put in 3.14 r squared. In order to get to r, we have to isolate r squared first. So I'm going to undo and divide by 3.14. Okay, so that's going to give me 16 equals r squared. So in order to get r from r squared, you need to square root. You get 4, so that would be my 4 inches. All right, so that is all my examples. Hope it was helpful. So your job is to do all the try problems, and then we'll check those answers later on in the week. I'm signing off right now. I hope you and your family have a great spring break, and I look forward to seeing you when we do lesson 7.2. Don't forget, if you have any questions, you can email me or come to my Hangout. Thanks a lot. Take care.